So for this video, I will be discussing Math 9 module quarter 2, weeks 5 to 6. So weeks 5 to 6 is about simplifying radical expressions. So a radical is in its simplest form if, number 1, the radicand does not contain a perfect square, cube, or nth power. So examples, square root of 2. So square root of 2 is in its simplest form since 2 is not a perfect square, meaning the square root of 2 is not exact. Then another one, cube root of 5 is in its simplest form also since 5 is not a perfect cube, meaning the cube root of 5 is not exact. Okay? Then for number 2, there is no fraction in the radicand or no radical in the denominator. Okay, so for example, square root of 3/4. So in the radicand there is a fraction. So you need to simplify this one. Okay, so if we're going to simplify this one, this will be square root of 3 over square root of 4. And square root of 4 will be 2. So the answer will be square root of 3 over 2. Now since the denominator here is not a radical, so this is now in its simplest form. Then third, the radical is in its simplest form if the index of the radical is the lowest possible index. So example, 6th root of 8 is not yet in simplest form since the index 6 can be expressed as the product of 3 and 2. Okay, so to simplify, express it as square root of cube root of 8. And it will be equal to square root of 2 since the cube root of 8 is 2 and square root of 2 is not exact. Okay, so you have to simplify radical expressions with 1, a perfect nth factor, 2, a fraction radicand or denominator, 3, reducible index. Then recall that a to the power of m over n is equal to nth root of a raised to the power of m. So a, nth root of a to the power of m is a radical expression which indicates the nth root of a to the power of m. B, n is the index which gives the order of radicals, and c, a to the power of m is the radicand, the number within the radical sign. So we have discussed this one in week number 4. Then there are properties being used in simplifying radical expressions. So these properties are the following. So first one is nth root of a times b equals nth root of a times nth root of b. So the nth root of a product is equal to the nth root of each factor. Number 2, nth root of mth root of p is equal to n times the mth root of p, or we can have this one as mth root of nth root of p. This is also equal to that one. So the nth root of the mth root of a number is equal to the n times mth root of the number. Then number 3, nth root of p over q equals nth root of p over nth root of q. So the nth root of the quotient is equal to the nth root of the numerator and the nth root of the denominator. So let's have the next one, simplifying radicals by reducing the radicand. So reducing radicand is finding a factor of a radicand whose indicated roots can be found. So this one is an application of nth root of a times b is equal to nth root of a times the nth root of b. So for number 1, simplify square root of 50. So 50 is not a perfect square, therefore you have to find a factor of 50 which is a perfect square. Okay, so we can have 50 as 25 times 2. Then 25 here is a perfect square, so we can have square root of 25 times 2 equivalent to square root of 25 times square root of 2. Square root of 25 is 5, so our answer should be 5 times square root of 2. Therefore, square root of 50 is equal to 5 times square root of 2 in simplest form. Number 2, simplify cube root of 81. So for our solution, the factor of 81, which is a perfect cube, is 27. Okay, so cube root of 81, 81 is 27 times 3, so we are going to have that one as cube root of 27 times 3. Then cube root of 27 times 3 is equivalent to cube root of 27 times cube root of 3. Then cube root of 27 here, this is equivalent to 3 since 3 cube is 27. So our answer shall be 3 times the cube root of 3. Therefore, cube root of 81 is equal to 3 times the cube root of 3. Number 3, simplify fifth root of 32x to the power of 7, y to the power of 5z. So for the solution, to get the root of variables with integrals exponent, the exponent must be divisible by the index. So in here, we're going to apply nth root of a to the power of n equals a. So our aim here is to make the index n and the exponent of the radicand equivalent so that we can simplify. So for example, if we are going to have fifth root of 32, we can have 32 as 2 to the power of 5. So this will become fifth root of 2 to the power of 5. Okay. Then x to the power of 7, this is x to the power of 5 times x squared. Then copy y to the power of 5 since they are just the same. Then z. Okay. Then applying nth root of a to the power of n is equal to a. So we can have fifth root of 2 to the power of 5 as 2 in here. 2. Then x to the power of 5, or fifth root of x to the power of 5 here is x. So x, 2x. Then y to the power of 5. So fifth root of y to the power of 5 is y. So we are going to have here 2xy times the fifth root of the remaining number. So the remaining here are x squared and z. So our final answer is 2xy times the fifth root of x squared z. Number 4, simplify 5 times the fourth root of 48, a to the power of 4, b to the power of 5, c to the power of 6. So for the solution here, we're going to first factor 48, in which one of the factors is a perfect power of 4. So the factors of 48 will be 16 and 3. So 16 times 3. Then a to the power of 4 in here. This is a perfect power of 4. Then b to the power of 10, we can express b to the power of 10 as b to the power of 8 times b squared. And c to the power of 5, we can express that one as c to the power of 4 times c. Then applying nth root of a times b equals nth root of a times nth root of b. We can have second statement as 5 times the fourth root of 16, a to the power of 4, b to the power of 8, c to the power of 4, times the second factor, fourth root of 3, b squared, c. So, if we're going to have the fourth root of 16, this is 2. 16 is 2 to the power of 4, so the fourth root of 2 to the power of 4 is 2, so 5 times 2. Fourth root of a to the power of 4 is a. Then fourth root of b to the power of 8. So 8 divided by 4 is 2. So we're going to have b squared. So 5 times the quantity of 2ab squared. Then fourth root of c to the power of 4. In here is c. So there should be c here. So this should be 5 times the quantity of 2ab squared c times the fourth root of 3b squared c. Then multiplying 5 times 2ab squared c we can have 10ab squared c times 4th root of 3b squared c. So this is our answer. Next is simplifying radicals by reducing the order of radicals. So to reduce the order of radicals is to reduce the index to its lowest possible number. Example number 1, simplify 8th root of a to the power of 12. So in here, our aim is to apply nth root of a to the power of n equals a. So we're going to make the index and the exponent of the radicand the same. So in here, a to the power of 12, we can express that one as index 8. Okay, so a to the power of 12, we can express that one as a to the power of 8 times a to the power of 4. So index 8 and exponent 8. So we can apply this one. So 8th root of a to the power of 8 is a. So our answer should be a times the 8th root of a to the power of 4. So changing this one, 8th root of a to the power of 4 to exponential form, we can have a times a to the power of 4 over 8. 4 divided by 8 is 1/2. Then simplifying or changing this one to radical form, 1/2 or a to the power of 1/2 is equal to square root of a. Therefore, 8th root of a to the power of 12 is equal to a times the square root of a. Number 2, simplify 4th root of 25. So since 25 is a perfect square, we can just reduce the index as square root of the square root of 25. Okay, so this is applying nth root of mth root of a is equivalent to n times mth root of a. Okay, so again, 4th root of 25, this is just equal to square root of the square root of 25. Then square root of 25 is this is a perfect square. 25 is a perfect square. Square root of 25 is 5, so our answer will be square root of 5. The number 3, cube root of the square root of 64. So 64 is a perfect square. So square root of 64 is 8. So we can have that one as cube root of 8. Then cube root of 8, this is also a perfect cube. 8 is a perfect cube, so cube root of 8 is 2. Number 4, simplify 6th root of 27m cubed n cubed. So for the solutions, express first 27 as power of 3. So 27 is equivalent to 3 cubed. So we're going to have 6th root of 3 cubed, m cubed, n cubed. Then the 3 radicand here, this is exponent 3. So we can just express 3 cubed, m cubed, n cubed to 3 quantity of 3 mn cubed. Okay. Then changing this one to exponential form, 6th root of the quantity of 3 mn cubed is equivalent to 3 mn raised to the power of 3 over 6. And this is equal to 3 mn raised to the power of 1/2. So 3 over 6 is 1/2. Then changing this one to radical form, this is square root of 3 mn. Number 5, simplify 8th root of 81. Now, since 81 is a perfect power of 4, so we can just express 8th root of 81 as square root of 4th root of 81. Okay? Then 4th root of 81 is 3, so we can just have our answer as square root of 3. Next is simplifying radicals by rationalizing denominators. In a radical expression, if there is radical number in the denominator, the expression is not in simplest form. So to eliminate the radical number in the denominator, you should apply the rationalization process. To rationalize denominator, you have to multiply the numerator and denominator by a number such that the resulting radicand in the denominator is a perfect nth power. Example number 1, square root of 3 halves. So what we're going to do here is we're going to multiply the numerator and denominator by a radical that will make the denominator a perfect square. So since the denominator is square root of 2, so we're going to multiply both the numerator and denominator by square root of 2. So if we're going to multiply this one by square root of 2, it will become square root of 4. Then the numerator, square root of 3 times square root of 2, that will be square root of 3 times 2, square root of 6. Then square root of 4 is 2, so our answer should be square root of 6 over 2. Now in here, there's no radical number in the denominator. So this is now in simplest form. Number 2, simplify cube root of 48 divided by cube root of 6. So in here, the denominator is a radical. But in here, we can apply quotient law. So we can just simply have cube root of 48 over cube root of 6 as cube root of 48 over 6. And 48 over 6 is 8, so we're going to have cube root of 8. And the cube root of 8 is equal to 2. So our answer here is 2. Number 3, simplify cube root of 32 over 54. So this one is equal to cube root of 32 over cube root of 54. So this should be cube root here. Okay. Then we can express cube root of 32 as cube root of 8 times 4. Then cube root of 54 as cube root of 27 times 2. Since cube root of 8 is 2, so we're going to have here 2. Then times the cube root of 4, the remaining number. Then cube root of 27 is 3, so this is 3 here, times the remaining, which is cube root of 2. Then we can combine this 2 here, cube root of 4 over cube root of 2. So we can have that one as cube root of 4 divided by 2. 4 divided by 2 is 2. So this is equal to cube root of 2. So our answer is 2/3 times the cube root of 2. Example number 3. Simplify 6 times the 4th root of 3 divided by 4th root of 2. So in here, we're going to find the smallest possible number where you can extract the 4th root. Since the radicand in the denominator is 2, you need to find a number. When multiplied by 2 will give you a number where you can find the 4th root. In this case, the radicand in the denominator must be 16. Thus, multiply both radicand by 8. So we're going to multiply here square root of 8 over square root of 8. Okay. Then multiplying that one, we're going to have this result here. 6 times the 4th root of 3 times 8 over 4th root of 2 times 8. Then 2 times 8 is 16, so we're going to have here 4th root of 16. Then for the numerator, 3 times 8 is 24. Then 6th root of 4th root of 24 over 4th root of 16. This is a perfect power 4. 16 is a perfect power 4, so we're going to have 4th root of 16 equivalent to 2. Then simplifying, 6 divided by 2 is 3. So our final answer is 3 times the 4th root of 24. Next is conjugate of radical expression. So examples, radical expression 3 plus square root of 2. The conjugate here is 3 minus square root of 2. So if the operation is plus, conjugate will become minus, the opposite. And the operation is minus, the conjugate is the opposite, it will become plus. So square root of 5 minus square root of 2, its conjugate is square root of 5 plus square root of 2. So the product of the radical expression and its conjugate is an integer. In finding its product, is the same procedure in multiplying the sum and difference of two binomials, like quantity of x plus y times quantity of x minus y is equal to x squared minus y squared. So this is the one that we're going to apply for conjugate of radical expression. So finding the product of radical expression and its conjugate. So if we're going to have letter A, quantity of 3 plus square root of 2 times quantity of 3 minus square root of 2. So the result here is 3 squared, which is 9, then minus square root of 2 squared, it's 2, so 9 minus 2, and the result is 7. Letter B, quantity of square root of 5 minus square root of 2 times the quantity of square root of 5 plus square root of 2. So we're going to have square root of 5 squared, that will be 5, minus square root of 2 squared is 2. So we're going to have 5 minus 2, and the answer here is 3. So if we're going to rationalize the expression, 3 over 2 minus square root of 3, so we'll just multiply its conjugate. So the conjugate for 2 minus square root of 3 is 2 plus square root of 3, so multiply 2 plus square root of 3 for numerator and also for denominator, 2 plus square root of 3. Then multiplying, this will become 3 times the quantity of 2 plus square root of 3 over, for this one, this is 2 squared, that will be 4. Then minus square root of 3 times square root of 3 is 3. So our answer will be 3 times the quantity of 2 plus square root of 3 over 4 minus 3 is 1. So our final answer is the numerator, 3 times the quantity of 2 plus square root of 3. Learning task number 1, A. Simplify the radical expressions. So we're going to have number 1 as our example. So square root of 63. So in here we're going to apply nth root of A times B is equal to nth root of A times the nth root of B. So what we're going to do is we're going to find the factors of 63, in which one of the factor is a perfect square. So square root of 63, we can express that one as square root of 9 times 7. 9 times 7 is 63, and 9 is a perfect square. Then applying nth root of A times B equals nth root of A times nth root of B. So we can have this one as square root of 9 times square root of 7. Square root of 9 is 3, so our answer will be 3 times square root of 7. Letter B, simplify radicals by reducing the order or index of radical. So again, we're going to have number 1 as our example, 6th root of 16. So 16, this is a perfect square, so we can just express 6th root of 16 as cube root of the square root of 16. Okay. Then square root of 16 is 4, so we're going to have our answer as cube root of 4. Learning task 2. Find the product of radical expression and its conjugate. So for number 1, the radical expression is 3 plus square root of 5. So its conjugate will be 3 minus square root of 5. And for the product, we're going to have 3 squared, that will be 9. Then square root of 5 squared, that will be 5. So 9 minus 5, that will be equal to 4. Letter B, simplify by rationalizing the denominators. So number 1, 8 over square root of 2. So since this is square root of 2, so we're going to multiply the numerator and denominator by square root of 2 to make this one a perfect square. Square root of 2 times square root of 2 is square root of 4. And square root of 4 is equal to 2. So the denominator now is 2. And the numerator is 8 times the square root of 2. Then simplifying, 8 divided by 2 is 4. So our answer will be 4 times the square root of 2. So that's it for this video. Thank you for watching and see you next time.